Have you ever tried pushing a ball into water? Did you notice that as you try to force the ball inside, it seems like the water is also applying a counter force that prevents you from pushing it inside? This is because there is actually a constant upwards force in all fluids called upthrust. Hello friends, today we will learn about upthrust. Every liquid and gas are known as fluids, and like every matter, they have a density defined by their mass per unit volume, which makes them exert an upward force when an object is fully or partially immersed in them. This was first explained by a Greek physicist named Archimedes in his principle known as Archimedes Principle. This states that when an object is wholly or partially immersed in a fluid, it experiences an upward force known as upthrust, which is equal to the weight of the fluid displaced by the object. Like every upward force, upthrust reduces the weight of an object, just like your friend assisting you with an upward force reduces the weight of a bucket in your hand. This is why your bucket feels lighter when inserted in a well. Upthrust. A practical way to measure the upward force by a liquid on an object is to check the weight of the object in air and its new weight in that liquid. The difference in the two weights is the upward push by the liquid. But Archimedes says you can also derive this upward push by the liquid if you know the weight of the liquid displaced. To understand Archimedes, let's immerse the object again and study this liquid displaced. When fully immersed, we notice that the volume of liquid that rises is equal to the volume of object inserted. So a cube of 20 cubic centimeters would displace 20 cubic centimeters of water. Basically, Archimedes is saying that it is the weight of these 20 cubic centimeters of water that moves upwards that creates the upward push called upthrust. So how then do we get the weight of this 20 centimeter cube of water displaced? Now, let's touch the great formulas of physics. We know weight to be mass times acceleration due to gravity. In this case, mass of liquid displaced, since our concern is the weight of liquid displaced. And from the density formula, we can derive this mass of liquid displaced by multiplying the density of the liquid and the volume of the liquid displaced. The density of water is a constant, 1000 kilogram per cubic meter, or 1 gram per cubic centimeter. So, if we substitute our values from our experiment, the upthrust of the water on the cube is 0.2 Newton. Wow! The same as the initial figure we got. Archimedes was right. The weight of liquid displaced is equal to the upthrust of the liquid on the object. If we shake things up a little bit by immersing half of the cube, the liquid displaced would also reduce by half, and the upthrust will be much lesser. This upthrust produced, when compared to the weight of the object, determines whether it floats or sinks. If the object's weight is greater than the upthrust, the object sinks. But when the object's weight is equal to or less than the upthrust, the object floats. So if I immerse a beach ball and the same cube in water, the larger volume of the beach ball will try to displace an equal volume of water. And because the empty space in the beach ball makes it less dense than water, the weight of its equal volume of water will be more than its own weight, making it float, while the cube sinks because its weight is more than the weight of equal volume of water it tries to displace. This explains why a large ship floats on water, because the weight of water the ship tries to displace is more than its own weight. This weight of liquid displaced, or upthrust, can be increased if the density of the liquid is increased. So, the same cube that sank in water would float on oil, because the larger density of oil gives it a larger upthrust. So, do you understand principles of upthrust now? Now, let's try some questions.